Right, I think we should start. It's gonna go on YouTube later, so anybody who wants to see it will see it. So, welcome. This is the second live stream. I hope everybody has been healthy and happy, and that I hope you had a good week. And yeah, today we will be doing some very cool stuff. On top of that, guess what? It's Friday. It's really good stuff. What we will be seeing today specifically is FSR 2. Now, FSR 2 is an upsampling algorithm. Specifically, what it does is it takes a frame which renders at a low resolution, say 1080p, and then it upscales that to a higher resolution, say 4K or 2K, right? So the meaning of that is that it costs less to render a frame which is of a lower resolution. It's cheaper. And compared to my previous stream, if you remember the first stream we did on Spartan, which was an introduction, this is going to be way more technical, which means we'll jump straight into the code, and I will be explaining less things by default. But if somebody asks me specifically about something, you can do that in the chat, by the way. I will of course stop and explain everything you need me to explain. And also the subject that we will be dealing with, FSR2, is more complicated. So it's going to be a more technical stream that is going to be fully grasped by people with experience, I guess, like people who already write code and so on. But even for younger people with less experience, like students and so on, I'm going to make sure that I explain everything you ask. So don't be afraid to ask anything. So the first thing we're going to do is we're going to open my engine, and I'm going to show you a little scene I have prepared. And that scene is a scene which has some aliasing issues. You know, it's a scene that's really good for upscaling, meaning if we get things right, that scene will look much better, much more stable. So I'm gonna load this scene. That's the scene, right? A simple Minecraft scene. And what you're gonna notice is that, well, we are rendering at let me make the viewport bigger, by the way. Make it quite bigger so you can see things easier. What you'll notice is that we are rendering things at 720p. That's quite low. And we are upscaling linearly, so we're just stretching the frame. We're not doing anything special. To 2K. So we will be really pushing the algorithm. We're not playing around. We're going to do some serious upscaling. If we manage to make this look good, then we're perfect. So let's see the issues of rendering at 720 and simply stretching the image to 2K. Let's see how it looks, how bad it can look. The first thing you can notice already, I hope, is that in the bushes, this simplistic vegetation here, you will see a lot of movement, lot of simmering, lots of pixels coming in and out of existence. That's one thing of low resolution. Of course, another is what? Is the fact that it is a little bit blurry. But for me, the more distracting part is the pixel crawling that you see. For example, observe these fences here and look how much alias they are and how they basically warp a little bit. Lots of aliasing, right? And because this is a voxelized scene, we have a lot of hard edges. Hard edges in a voxelized scene like that make it easy for us to see that, you know, upscaling naively from 720 to 2K linearly, just stretching the image again, you're simply not getting good results, right? And there have been techniques like FSR 1, which, if you look closely, it makes things a little bit sharper. So to see that again, focus on a particular area. Pick a bush somewhere here. So focus on it, right? Keep your eyes on it. And now I'm gonna switch to FSR 1. So it does make things a little bit sharper, which is great. However, FSR 1 is fantastic, but it doesn't have all the data it really needs to get rid of this pixel crawling. So it's still there. So upscaling to recap, from 720p to 2K, which is quite a jump, is not easy. You get a lot of noise. So our goal would be with FSR 2 today, if we get it right, to make FSR 2, make it upscale this thing and make it look as good as native. And by the way, now that I mentioned native, let's see how a native 2K image looks. As you can see, everything became sharper, and the pixel crawling in the bushes is greatly reduced. However, you will notice that even at native 2K, there is some simmering in the background. You can see that it's not perfect. There is a little bit of aliasing there, but it's much better, right? But of course, we're gonna push it. So 720p, lots of crawling, lots of blurriness, lots of noise. So the first thing is, we close the engine. You have an idea of what we will be doing now. I close this as well, and I go on GitHub. And specifically on GitHub, FSR 2 has been published. It's completely open source. And by the way, I haven't worked on FSR 2, never. I wasn't part of the team. I haven't used it before. So this is me also trying this, seeing this the first time, like you. The first thing that you will notice, apart from the source code obviously, is that it has amazingly good documentation. I mean, look at the table of contents here. Look at that. It's massive. It's massive, absolutely massive. They explain everything, from the very basics to how to start, like build, like click this script and create a solution and then copy this here and that there. It's like extremely detailed. And it goes on and on and on. It's absolutely massive. Look at this. And it goes into great detail towards the end, from what I've seen a little bit just before the stream, to explain even more, more technical concepts. So this documentation is basically hand-holding me. It's one of the reasons I felt so confident and safe doing this live right here, because of how good the documentation is. And on top of that, it comes with a sample, I think. So the first thing we're gonna do is I'm gonna clone this repository. So to do that, I'm gonna copy this link, and I'm gonna open a Visual Studio instance. These days I do everything from Visual Studio. It has CMake in it, you can clone stuff from GitHub. Visual Studio is the way to go. So what I did, just for the people who haven't done it before, I just pasted the link here of the repo, and now I'm gonna paste the link here, or I'm gonna point it to a path basically, where I want FSR 2 to live once we download it. I'm gonna create a folder called FSR 2, and it's gonna grab everything and put it there. Now that might take a minute or two, and once it's done, you know you have everything. While this is happening, let's look at the documentation and let's see where we will start from. The first thing is, I think this, quick start checklist. So this guides you on how to start from nothing, from building the, downloading and building the library, to actually using it inside your engine. So the first thing it says is double-click generate solutions in the build directory. So there is a script that will generate everything automatically. And then we simply have to build the solution. So we have to produce the libraries, I would assume, or FSR 2. And these libraries is what will link into the project. So let's see if it has finished. It needs a little bit more. It's quite big, but I have a fast connection, so they should be done in a few seconds now. And after that, we can start. And by the way, to do FSR 2, to integrate it into your engine, how easy or difficult it is depends very much on the state of your engine. So if your engine is a modern engine, or you have a modern game or whatever, which has TAA in it, and the concept of jittering the projection matrix is already there, or the concept of render resolution and output resolution is separate. If you have stuff like that, if you have a modern engine, then it should be easy. That's our case with my engine. If your engine is a little bit older tech, there is more work to do beyond this stream. So yeah, Now that's downloaded. And if you remember from the README file here, it said click this script, generate solutions in the build directory. So we're gonna do just that. I'm gonna go here. I'm gonna grab this. I'm gonna click on that. I'm gonna go in the build directory, and there is the generate solution script. I'm gonna click that. I can see it's looking into the Vulkan SDK folder. So I'm assuming that you have to have, of course, SDKs and stuff like that for either Vulkan or DirectX 12 before doing anything, right? In my case, I will be using Vulkan. It has become quite mature and stable in my engine, so that's a good way to go. And then it said from the README file here, right, to go and build the solution, which is the Visual Studio icon here that got generated from that script. So I'm gonna open that, and we should be seeing, right, okay, that's very nice. It has a sample as well. I like the samples because I like reading documentation, but I prefer to actually see code that I can copy and paste and modify, get an idea of how to do things. Now, I'm seeing the API here, which I assume is a library, but I'm also seeing a second API here. So I don't know if one of them is needed or both. So let's look to see what kind of stuff they do. For example, this scratch memory, get interface, physical device. It seems like this is the Vulkan interface for FSR 2. And this should be the more generic high-level interface. Yeah, stacks and stuff like that. So I'm assuming you need both. One is the main FSR 2 things, definitions. So that's the one. And the other one is the thing that glues FSR with your particular backend. In my case, Vulkan. If you clicked if you built the DirectX 12 solution, I would assume that you will be seeing a DX12 project here. So we're gonna build this too, but before that, I wanna make sure that there's a static library. That's cool. And I'm gonna make sure that the code generation, the runtime library, is a non-DLL library, multi-threaded debug. That's what I use in my engine, it's simple as that. So this depends on your project, how you wanna link to FSR 2. And from what I've seen from the build directory, it can even be a DLL, you can do anything. Right, so I'm gonna do that, and I'm only gonna build debug, and I'm only gonna work with debug in my engine, simply because I wanna finish this video in less than 3 business days, So one configuration, debug, it also is good for debugging, obviously. So we're gonna go this way. Let me verify all the options again. So multi-threaded debug, the debug information format is C7, that's brilliant. That's what I use always. I love that they went for it. Static library, cool. So we should be good to build this. It's starting to build, that's good. Imagine if an error happens here right now in the beginning and we can't build the library, the whole string. But I doubt it. It looks like a very well made repo. It's impressive. It's all good. So I'm gonna close this, and I'm gonna try to find these libraries first. Bin, I guess. Yep. Yes, just now. These are the libraries. Cool. So what else is it saying about the include files? Alright, so it's even telling us exactly what to include. Cool. So we're gonna start now integrating this into our project. I'm gonna grab these libraries, and I'm gonna go to my Spartan engine directory. And in this directory, third party, in case you want to contribute in the future, I'm explaining everything. I'm keeping all the third party libraries, obviously. And in the libraries folder, I'm keeping the actual libraries, the static libraries. In all the other folders here is just the header files. So if I go to libraries here, I'm gonna paste this to here, right? And now I'm gonna create a folder here. I'm gonna call it FSR 2. And obviously that's gonna have my includes inside there. And let's go to the close this window. Let's keep one window open. Source, I guess, has a few folders in there, so let's see what it says. So source, that's correct. Go to source and then into FFX, I guess it stands for Fidelity Effects, FSR 2 API. So there should be a library, directory like that. So there it is. And then FSR 2 header, types header, error header. So I guess everything that's a header file we copy. Right? Apart from, I don't see private and maximum bias. Cool. So everything that's a header, except from these two, is going in, and of course this. So I'm gonna go back to my engine. Actually, when I include the files, I wanna type FSR2 so I know they come from there. So I'm gonna do another FSR2 in here. And I'm gonna paste them. And let's see what else it needs. And say there's resources in common. Care should be taken to maintain the relative directory structure at the destination of the file copy. I think I know what it means here. That these files are referencing each other. So you can't just do this and take a file from here, from the shaders directory, and then go to your project and just paste it here. It won't work, because you have to maintain the relative structure, which means that if I'm to copy something from the shaders directory, I have to make a shaders directory in my engine as well and put it in there, I guess. That's what it's saying. And let's see. It's saying that we should copy common and resources. Do you see a common? I see a common. There it is. So we put the common in there. And resources. Do you see the resources? I see it here. Perfect. Good. And then it says copy the header files from the particular API that you're using. It has direct textual field, for example, but we will be using Vulkan. So Vulkan, FSR, Vulkan, and shaders. Okay. So let's go back here. Let's go to Vulkan and copy that. And again, I would assume it wants me to maintain the relative hierarchy of the directories. So VK, right? And in the VK directory, I'm gonna paste this. That should be good. And now, another directory within that called shaders. And within that, it's asking us to copy. It's just one header file. Cool. Okay, so that was quite tricky. Like, you have to be careful to maintain the directories, because these things reference each other. If you don't maintain the directory structure and just copy all the header files in the same root directory, chances are, because they reference each other, it will not compile. And with that, I think we have successfully copied all of the include files correctly, and we have the directory structures. Cool. So I'm gonna close the FSR2 directory, and I'm gonna minimize that window, and I'm gonna go to the root folder, the root directory of my engine. And in that directory, there's another directory called build scripts. Now this contains a pre-make file, and that's because I use pre-make to generate the Visual Studio solution. And that's basically a Lua script. And in there, I'm gonna just tell it, there is an FSR2 library, there are these headers, just make sure you link them into the project once you generate it. So let's do that. This is very product specific, so you don't have to worry about this. And I don't even need to explain it too much. This is just specific to my engine. So I'm just gonna quickly add an FSR2 directory. Third party, FSR2. Good. And we're gonna make sure that it's included in the runtime. That's the core engine, right? but also it should be included here as well. Let's copy that again. That's the editor. That's because the editor is using the renderer everywhere. So I'm pretty sure something might leak, something, you know, it might need a reference to FSR 2 or something, which shouldn't really happen. But because I don't want any simplistic issues like that in the stream, because they will take time, I will just include it everywhere and be done with it. So we have the includes now linked to our projects. The next step would be to add, for the debug configuration, the libraries that we generated, the static libraries. So let's make a copy and then go to libraries and find FSR. That's the main library, and let's go here and put it here, and then make another copy of that. And here we will add the Vulkan backend, which is the glue, I guess, between FSR and the Vulkan backend in our engine. Excellent. And I will copy this, and we will add them also in the editor. Perfect. That's good. And now we should be able to go to the root directory of my project, of my engine, let's say, and click generate solution, Vulkan. And it should generate everything and link everything correctly. And FSR2 is ready to go. We can get cracking. Let's check this. So, first thing I'm going to do is just try to rebuild everything and see if it compiles and everything is good. And while it's doing that, let's check if, I know, things are there. Like, we actually got a new project. Yeah, FSR2, okay. So, the engine now is aware of the new library, and the rebuild succeeded. Excellent. So now, we are starting FSR2. But we'll actually implement it. And for that, you could totally read this. It's very detailed. But I love to read code. And the good thing is that they have, if you recall, in our FSR2 directory, in the, what was it, build folder, VK, yes, that has a sample in it as well, apart from the libraries. We're gonna tear the sample apart. And we're gonna copy bits of code, I guess, to what extent we can, and modify them. I think that's the fastest way to do it, again, in less than 3 business days, in a single stream. So, FSR2 sample, I think this is only UI and GUI, it's just the beginning, the Windows stuff. So, what is the core FSR stuff happening? Context maybe? FSR2. Physical device, that's low level, that's good. Yeah. I'm saying FSR2 calls here. A dispatch, yeah, bunch of text, I think that's it. So, right, we're gonna use that sample. We're gonna start it a little bit now, and we're gonna put things in my engine and see how it goes. By the way, in my engine, we will be replacing FSR1. Yeah. So, let's see. The first point of interest, I think, is here, where it creates the FSR2 context. That's actually, you know, creating FSR, starting FSR, initializing it. Call it however you want. It fills some parameters here, render resolution, and display resolution. I guess this is the output resolution. In my engine, that's the name distinction I have. So there is the render resolution, and the output resolution. And I'm about to sneeze. And the render is 720p for us, what I showed you before. It's going to be like that. And the output for us will be 2K. And this should be the Vulkan interface. It's just a bunch of callbacks, I think. So it's hooking up to Vulkan. And what kind of callbacks are there? Is it that? Yeah, that's the case. create device, destroy device, get resource, create pipeline. Okay, so basically it's all the functions they need to make FSR work in the background. Vulkan specific functions. So that's all this is doing. It's where were we? It's hooking up to some Vulkan functions, and then here we just create the context. Cool. And this is happening on create window size dependent resources. So that's a resolution change. It makes sense. So that's what I will put it in my engine as well. When we change these resolutions, render and output, I have a specific function actually for that. That we can hook this in and get the render resolution and the output resolution and initialize things correctly. So I say we start with that, and include the headers and see if it compiles without even dispatching anymore. I'm gonna copy all that, just like that, and I'm gonna find this function that I told you. Why do I have two solutions? That's just one is enough. Cool. I'm gonna go to a function. I'm gonna show you here so you learn a little bit about my engine. Somewhere here there's a function called create textures. There you go. That's not it. It's another one. Create render textures, I'm sorry. Render textures are obviously anything that's used for rendering by the engine. And as you can see, it's doing exactly what we want. It's separating the concept of render resolution and an output resolution. And that's very good for us. We're liking a way. That's why I'm saying it really depends how easy FSR 2 integration is, depending on what your engine is. And then it's creating some textures that want to be created in a render resolution and others in an output resolution. And that's basically my output buffer. So I'm going to go to the bottom of this function, which I assume is the right place. And I'm going to write this FSR 2 stuff. I'm just joking. We're going to call it FSR 2 setup. Much better. I'm going to paste all this stuff, let's say. And we will adapt it now and see if we can get it to compile. So the first thing, let's take care of the context. I don't need any memory stuff for now, for this video. I do want to see these functions being recognized, so we want some headers. Visual Assist doesn't want to help me out, so I'm going to go and manually, sorry, this is the bit. I'm going to include FSR2 .h. So that should help Visual Assist. Yeah. I'm curious as to why I cannot pick it up. Usually it does. You cannot even do that. Okay. That was the Vulkan specific function from FSR2. So FSR2 VK, I guess, right? That should do it. Yes, thank God. I'm very happy so far in this stream. Everything is going according to plan. Like, imagine not even trying, like, not being able to build things or include a header. Yeah, right. Let's start now with the inputs they take. So the context, it takes a context, of course. So I'm gonna go to the header file of my renderer. Oh, come on. And I'm gonna go to the very bottom, and I'm gonna add a new section. And in this section, I'm gonna type FSR2, and we're gonna add the context. FSR2 context. And you know what? Since we have it in the header now, I'm gonna take this away from here because we're gonna need it here. I'm usually forward declaring everything in my engine, but again, for the sake of this live stream, I just want to get things done. That's picked up. Great. And we can go here now, and we can say M stands for member, by the way, for those of you who are younger developers. FSR2 context. Cool. And now let's see what this initialization parameters is. Context description, actually. It's called differently. That's interesting. So let's go here and let's do FSR2 context description. As you see, I like to be very verbose in the naming of my functions and variables. It's like I'm writing an essay. But the good thing with that is that when I come back, say a year from now, and I look at this bit of code, I know exactly what it does. It's so much easier. So I would suggest this. Don't try to be smart when naming variables, or because basically you're fighting your future self. Yes, sorry, did we name it correctly? I forgot myself. FSR 2 context creation. I'm gonna copy that, and I'm gonna pass it right here, and I'm gonna replace all of these with that, and this as well. Now, I'm gonna align everything. Don't laugh if you do, but I like things to be symmetrical. If they're not, I don't know, I don't feel well. I get anxious. I mean, I must have an issue or something. But I like things to be aligned. So, these are the flags and stuff. High dynamic range. Okay, we have to give the correct flag. So I am using high dynamic range. I have indeed reverse Z, inverted depth. And I'm not doing anything myself exposure-wise, so I guess you could do auto exposure if you need to. What does it say about exposure though? What do they recommend? And we find out. Any recommendations? Therefore, it is recommended that the exposure flag is used by the application unless there is no particular reason not to, because poorly selected exposure values can have drastic impact on the panel quality. Okay, I'm not doing my own exposure and I'm not going to mess with it. It says that it wants it to be perfect, so we'll have good results. So go ahead and do dynamic exposure if you have to. Do whatever you wish. So these are my flags. Let me see what other kind of flags they have for creating the context. Display resolution motion vectors. So for me, that's called velocity buffers. And I don't have them at output resolution. I have them at render resolution. So if we're rendering at 720p, our velocity buffers will be 720p is what I mean. Motion vectors, jitter cancellation. I remove the jitter because I have the already. So, I use the jitter to remove it basically from the velocity, so that's good. Inverted depth, infinite depth, no, I use a far plane, I guess that's what it is. Yeah, my far plane is actually fine, it's a specific value. Auto exposure, we added that. Dynamic resolution, we're not doing that yet. And I think that's why here, where was it guys? Instead of saying display size and render size, it says max render size. I think it's because of the dynamic resolution. So if you're using dynamic resolution, you simply define the maximum possible here. In our case, max render size equals render size because we don't have dynamic resolution. So I'm gonna go, and because the engine structure pretty clean, I would like to believe, it's very convenient. We already have the render width, for example, which is the core rendering resolution, and we have the height, the render height, and also we have the output. Width output. By the way, if I make any mistake, these are simple mistakes that can cost a lot to debug them later. If you spot anything simple, like it's asking for a width, but I'm typing down a height, please let me know so we can avoid, head scratching later. Height, output. Cool. And now the last thing I see is Vulkan specific stuff. Now I never expose Vulkan specific stuff high level in my engine. I have my own API that wraps both Vulkan and DirectX, all DirectX versions. Let me show you. 11, 12 Vulkan, and it's called RHI. But for the sake of this video again, we're gonna give it everything it wants. We don't care. I'm gonna fix this later. You don't have to experience the pain with me. So RHI device, and then get RHI context, and here in my little engine I keep all the specific stuff hidden within if-there statements, so they never compile in different for different backends. And it wants a device, right? or a physical device. What was it? I should have been more careful. Physical device. That was close. Device physical. There you go. It needs a header. Hopefully Visual Assist will help me this time. Thank God. Finally. We decided to add a header for us. Another physical device. And here, a device. A VK device, I would like to believe. Yeah. Okay, so it's actually just requiring vanilla Vulkan stuff. So, this is Vulkan callbacks setup, right? It's very clear. Actually, we don't have the type setup because we already say here FSR 2 setup. So the Vulkan callbacks, and that's the actual context initialization. Yeah. Now the first thing I want to do is see if that thing will compile, because now we're using FSR stuff in our engine. So let's see if it compiles. We forgot to add the resources. Really? Okay. Where is that from, guys? Okay, let's see. Let's go back and go to Spartan. This should be easy, no worries. Third party, FSR 2, and what is complaining about? Shaders. You know what? Look at that. You see how tricky it is? I spotted the error already. Can you spot it? Probably you can. It's fine. It's very small. Instead of typing shaders, I'm typing shader. So that should fix it. Unbelievable. Extremely. You have to be extremely careful when you include them. And there you go. Easy peasy. Let's see if it runs or it crashes. Fantastic. Of course, we're not rendering anything yet, so we cannot test anything, but it's really important that we're creating an FSR 2 context and we're not crashing and all this stuff is going fine. So, next step. The next step would be to go to the sample and I guess go to the place where it just launches all the work with a dispatch. I'm very happy that they hide everything within a single dispatch call, and all we have to do, from what I understand, is fill in a struct, a very verbose struct. I can see already color, textures, I guess, yeah, depth, motion vectors, exposure, reactive mask. I think I know what this is, I'm gonna tell you later. Jitter. Everything is there. Okay, so I'm gonna copy this again. Same process. I'm gonna put it in my engine. Let's go to passes. Oh. And in post process is when I do my upsampling stuff. So I do some stuff here that has to happen in render resolution, and then I have a pass where it's upscales from render to output. I don't do anything fancy yet. I have a simple, silly, stretch with the bilinear upscale, and I have something much better, which is FSR 1, and we're gonna replace that. So in this place, you could totally keep FSR 1 in the engine, but I like to maintain as few things as possible because I'm just one guy working on this. So I'm gonna replace that with our own call. So let's make another call and another function. We're gonna need the scratch buffer for that, and I'm gonna call it FSR 2, sorry, and that's pretty much it. Now I'm gonna copy this implementation and I'm gonna put it right up below FSR 1, right? And now in my render passes, I'm gonna make sure that this is FSR 2. Now, as far as the editor is concerned, and all the names you will see in the editor, it's gonna say FSR 1, but whatever, for the sake of this video, we will just do it like that. And all it wants is an input texture, which is render resolution, so the low resolution, and the output, which might be something like 2K or 4K or whatever. By the way, that's an interesting point. I have a check here where I'm saying if the output resolution is bigger, is larger than the render resolution, then we need to upscale. But with FSR 2, you don't have to do that. You can not upscale and still use FSR 2. That's because FSR 2 is a temporal filter, so it can act as TAA. Yes, so that's really good news, which means that me putting this in my engine, not only I can get rid of all of my upsampling stuff that I have there, that I don't have to maintain anymore, I can even throw this away. Plus you get options like dynamic resolution and so on. So it's a blessing. It's a blessing, honestly. But for now, let's just replace FSR 1. So yeah, whatever. Let's leave it check here. And let's go to this function and then go to the sample and copy everything again and put it here. Just throw everything here. I think that's some sample specific stuff. Let's remove that. Now I'm gonna align everything and it's gonna take like a minute. Don't laugh if you do, but I'm telling you, I have an issue with symmetry. If things are not perfectly aligned, I just can't, I cannot do FSR 2, like I have to. Everything has to be aligned perfectly. So, let's put everything in place. Oh, nice. Jitter, oh, we have to work on the jitter. I will get back to that later. I have it already in my engine, but we will replace it with whatever FSR 2 wants. Wow, that's a lot of parameters that you have to pass in. It makes sense though. However, if that's all it needs, FSR 2, it's surprisingly well made. They have done a good job at hiding everything under the hood. And I say they because I might be working for AMD, but I'm not part of the FSR 2 team. So I have no idea what they're doing. Cool, let's start from the bottom because I see some easier stuff. It wants the camera, field of view, angle, vertical. I'm glad they're so specific and not just generic field of view, because that's exactly how I go about things. Get field of view, exactly the same way, vertical. In radians though, what do they need? The camera angle field of view in the vertical direction expressed in radians. So that's exactly what we have. I'm very happy. They follow also, I mean, we follow each other's naming conventions and ways to do things. Camera near, get near plane, that's the near plane of the camera, right? And camera far, remember I'm not using an infinite far plane, so I'm gonna go camera, and I'm gonna get a far plane, and I forgot this all over the place. Cool. And now that's the render size, render width. I guess that's a native. Let's hope it's a native render resolution. Good. And now the height, we have this as well. It's the same, but the Y. Pre-exposure, what's that? Pre-exposure. The exposure value if not using the auto exposure flag. We're using auto exposure flag, so I guess this doesn't really matter, but let's leave it there. Delta time in milliseconds. I have it in seconds, so we have to convert it. By the way, I am not a fan of dynamic casts, sorry. I'm a fan of static casts when possible, even if they're more verbose and longer. I like things to be explicit and happen in compile time and so on if possible. Float, and I have a constant buffer CB frame which should hold, if we're lucky enough, the delta time. Perfect. Remember, my delta time is in seconds, so to make it into milliseconds, what do we have to do? We have to multiply by 1,000, and we'll get the time from seconds to milliseconds. That's because 1 second is 1,000 milliseconds, right? Pretty simple. Sharpness. 0 to 1. Let's start with 0. In the beginning, I will not use any effects. Also in my engine, I have everything turned off. No fancy effects. It's very plain on purpose because I want to see how it looks as native as possible. Enable sharpening, false for now. Reset, that's interesting. Oh. What's the reset? A Boolean value which when set to true indicates the camera has moved discontinuously. Makes sense. If you have TAA, if you work with TAA, you know exactly what it means. Because it's accumulating stuff in a history buffer, I guess. Because it's a temporal filter. If the camera moves from one place, just teleports to something else entirely, then the history will have nothing to do with what the camera is rendering now. And even the velocity buffers cannot make up for it, for that change. So I guess when you teleport the cameras in your game or engine, this, for a single frame in that teleportation, has to be true. Now, in my project, I don't do that. And our demo is just us flying around the Minecraft village, so false. Motion vector scale, that's interesting. The scale factor to apply to the motion vectors. Scale factor, why is that? It's reading something specific, I guess. Some specific velocity. Does it have any velocity help? Let's go up, all the way up, so you can search properly. There's the motion vector scale. I want to see in what space they expect the velocity to be. Not sure I can see something. In any case, we're gonna go with what the sample does. I guess since it's using this render width and render height, it's probably screen space, like big numbers. So we're gonna give it big numbers. So that's basically render height, render width is basically that, exactly. It's already a float for us. So we're just gonna leave it as is. Now the jitter, that's interesting. We forgot about the jitter. The jitter, I'm gonna explain what this is because I have it for my TAA stuff. How on earth do I call it? Let's go to where I actually compute my jitter. It should be in the tick function in the renderer. And soon enough, I call it TAA jitter. It's not TAA at this point, it's more than that. It's TAA plus, let's say, FSR 2. But let's just pass it. These. Of course, I don't know if that's the jitter it wants. I'm sure it has a specific way to compute the jitter. So we're gonna go with what it does, which means I'm gonna do an else if. And else because you cannot have TAA enabled at the same time as FSR 2 because FSR 2 is a temporal filter, is TAA, and it's just more expanded. So TAA is a separate thing. And else if we're gonna add get option FSR 1, right? We're replacing FSR 1. So everything is called FSR 1 even though it's FSR 2. It's gonna become 2, hopefully. So this is the way that I jitter my projection matrix, which is to move it around a little bit. That's what TAA does. We're not going to go into the details about how this works, but basically what I'm doing is I'm taking a jitter and I'm creating a translation matrix, and I apply that, which means I multiply my projection matrix with it. This will move the projection matrix around a little bit, usually sub-pixel jitters, and that is what generates different samples, varying samples for the TAA or FSR2 to accumulate in the history buffer. It's basically why these staircase artifacts, all this stuff, you know, they start to overlap and they go out. Everything becomes smooth. It's the core of the core idea of temporal filtering. But we want to see exactly how it does it. So I'm gonna go to the FSR 2 sample, and I'm gonna search for this. Like, where do they do the magic? Right. Oops. So they have their own functions. We're gonna use these functions. Now this, they multiply by 2, blah blah blah, -2. I think this is specific to their own math library. So we don't need that. We'll just need what they do here. And we're gonna take that, and we're gonna use our jitter, X and Y. And here we're gonna use the render width and display width. All right, so that's resolution render X, right? And that's resolution render output. Oh, that was close. Resolution output X. So it wants, I guess, to compute a ratio. And that, of course, scales somehow the jitter offsets. I would assume that's what it's doing. But it's beyond the scope in looking into that. Actually, I would like to look something into that. I'm using a Holton sequence, 2x3. I'm curious to see how FSR 2 does it. They must say somewhere. Let's search for it. Ah, there you go. They're using a Holton sequence, 2x3. So chances are I could just feed them my own stuff. But I'm pretty sure, because FSR 2 seems to be quite cutting edge, they might even have specialized things they do. So I'm not gonna mess with it. Now the index, what kind of index is it? I'm using 60 samples, but here they just increment it indefinitely. So they must be doing a wrap inside there. Yes, they're wrapping it around the phase count. Okay, so we're gonna do that. We're not gonna mess with them. We're gonna give them exactly what they want. So I'm just gonna define a static uint32 here. I'm gonna name it index. Static because I'm too lazy now to go back to the render and make the proper member. Just do that. That's what worked, right? Put it here. So now, when FSR 1 or 2, I should say now, is enabled, we should be getting the jitter that it wants. And remember that it wants the jitter. It wants to be fed the jitter here before the dispatch. And now for the longer part, my friends. Putting in all the textures. Now the good thing is, from what I see in the sample, that should be the final bit. Believe it or not, if you did everything correctly, that should work. So last chunk of work. So the first thing is, I'm not going to be using a reactive mask. A reactive mask, by the way, in TAA as well, in many temporal techniques, is a mask on which you write objects that have no velocity buffers. And then this mask basically describes which pixels don't have velocity buffers. And this mask is very helpful because when you have this mask being active in certain pixels, then you know to accumulate less in your history buffer, which reduces ghosting. This is very helpful for particles and stuff like that. We don't have this in our demo, as you saw, so that means less work for us, so that's perfect. But the good thing is that FSR 2 supports all of that, and even more here. We're going to talk about this in a bit. So you can really push it to levels which will be, honestly, from what I've seen online, in all the games that use it, it's impressive that this is temporal. And it has so little ghosting. You have to push it really a lot to even see a little bit of ghosting. So transparency and composition, I guess, is for transparency effects and stuff like that. We're not using this, less work for us. But now, the output, of course, will output the texture. The exposure, we're using auto exposure. That's why it passes null there, I guess. So that should be good. And when I say we're using auto exposure, I mean, if you remember, that here we told it enable auto exposure. So I guess we'll see if it crashes or not. If you pass a texture here, right, but it's null internally, can we see it? No. It should pick up the fact that, oh, this is auto exposure, so probably allocates some texture, I guess, to do its own exposure. Right, now, the first easy thing, the context. FSR 2 context. Put that in. Put it in everywhere. Right, and I also see another Vulkan specific thing, the command buffer. Oh, we need to have the definition here. It got it on its own, finally. And, like for FSR, my engine can provide the underlying buffer as a void pointer, which it probably wants to cast to a command buffer, VK command buffer. Yeah, so let's do that. I'm copying this, static cast, VK command buffer, and I'm gonna pass the thing in there, and I'm gonna close it. Now, one more parenthesis, I'm sorry. Perfect. Again, I'm not exposing usually Vulkan, like low-level stuff in my renderer. I have my own API, but for this video, we will just do everything it needs. Also, I don't advise you to do this as well in a finished product. Don't expose stuff all over the place. And now we have a bunch of textures. We need the color. That's an interesting name. Color. I think that's basically the input frame, render resolution. And I think that's misleading a little bit, because color, I could be giving it the albedo, but it's not what it wants. It wants the input frame, I think. And here is the output frame. So yeah, be careful with that. I think that's the case, right? I doubt it will be needing the albedo for anything. So now the output texture, we have it here. The color of the function provides it, and the color, I guess, is the input texture. It's provided here. So we have these two. So what we want is the depth and the motion vectors. I call it velocity buffer in my engine. So let's get this render targets. It's very easy to do in my engine. I have a macro here, which you provide an enum to it, and then it casts that enum to an integer, 8-bit integer, and then it uses that integer to look into an array, right? So because I don't want to be that verbose, I have that here. So you can see that here perfectly well. I'm gonna copy a line here, and I'm gonna go to our FSR 2. We added it here, that's good. And I'm gonna get my textures. So first things first, guys, get textures. Cool. We don't want we want the depth. So depth, the buffer depth, and let's call it something meaningful. Text depth. And now I'm gonna do the velocity. Text velocity. By the way, I'm not staring the screen into writing the code. There's an actual keyboard here, in case you're wondering. So we have the depth and the velocity. Now, before anything, one thing that worries me already, because I've been fighting with Vulkan for months, fixing validation errors related to layout transitions and stuff like that. One thing that worries me is that it doesn't have knowledge of which resource, which layout they are. It cannot have a knowledge, so I guess we have to do it manually. Unordered access view here. Okay, so basically it needs some help. You know what? I'm not gonna risk it, even if it magically knows how to transition, which I doubt it does. Actually, you know what? We're gonna see what it does in the sample. So it passes all these buffers here, right? But before this draw, it must transition something. Yeah, there you go. There you see that? They do a memory barrier for 6 textures, and they do the transitions manual. So that's, did they mention that? Let's see if they mention that. So that's important. I mean, they have the sample that says everything. Now it's more high level here, and it makes sense. Otherwise, if it said even that, it would be like a massive, like an encyclopedia. Okay, so let's transition stuff. That was close. That was something that could cause us a lot of head scratching for a while. Transition to correct layouts. That might even be in the correct layouts. The engine will detect that and will not transition if that's the case. So I'm gonna start with the text scene, which is the first texture, and I'm gonna do set layout, and the image layout is shader read-only optimal, I guess. Okay, it requires an unresolved color resource view. That's an SRV for DirectX users. So because of that, I'm assuming that it wants set the read-only optimal layout. By the way, these are naming conventions derived from Vulkan. So for DirectX people, I'm sorry if it's not exactly the same, but you should be getting the idea. This is an SRV. And a command list, which I have here. In a similar manner, I'm gonna go to the depth, and I'm gonna say set layout, and that's gonna be depth stencil read-only optimal, not say the read, just like that. And we're gonna pass it the command list. Lots of typing, really, guys. I mean, most of the difficulty of FSR 2 so far, in my eyes, is just lots of typing. Now the velocity, set layout. Yeah, that's just the same. Say the read-only optimal. And while we're doing that, I'm curious as to what format it expects for the velocity, or any of the buffers for that matter. Let's go velocity. For the buffers, I guess any HDR format should do, since we have HDR enabled. But the velocity, perfect, it's right here. That's a depth buffer. My buffer is 32, by the way, so that's great. We don't care about that. Motion vectors specified 2 floats. Yes, that's what I have. Let's verify though. Let's go to my resources. You have to make sure also you're passing correct stuff, right? Velocity. Yep, 2 floats, 16B. It's good. It's great. And these are the input and output buffers, by the way. Yeah, if something goes wrong, we'll just figure it out. And what else? We have the velocity, and now we need to transition the output texture. Set layout. What layer is that? We had an order access here, which makes me think that it might be a general layout. If it's a UAV that it wants, Vulkan wants a general layout for UAVs and compute shaders. I'm not really sure. Is this getting another SRV though? You know what? I'm gonna wing it and we'll see what happens. We're gonna do another general, whatever, list. And okay, so we do take care of that to a first degree at least. We're transitioning the stuff before using it. And now for the most boring part, fix all this. Oof, that's a lot of stuff. So here it wants the width of these textures. Obviously, all these textures for me, all the inputs, not the output, they have the same resolution, which is resolution. That was width, right? Yeah. That's very easy to make a mistake here and then search for hours what it is wrong. That's the width again, same width, render resolution, everything is render resolution here. And that's the height, so the only thing I'm gonna do here is change it to a Y, and a Y, and a Y here. And that's the output texture, I think. Yep, that's the output. So that's gonna be M resolution, remember, out X, which is the width. And that's gonna be M resolution output Y, which is the height. Oh, what are these? WHRs, and probably some, who knows, Unicode, multi-byte formats, who knows what the heck is wrong, and it just doesn't like it here. In the sample it works, I guess. So I'm gonna define it locally here. I think it's gonna like it now. Let me do that. I think that's what it is. WCHAR and name color. It's the name of the color, and it's an array. And put that thing there. Perfect. We made it set up about it. And now I guess I could just use this there. Ah, thank God. Alright, I think it wants names for the textures, which you don't have to give, because Vulkan can support naming all the objects it creates. It allocates memory for, and that's very helpful. We're not going to pretend to be cool. We're going to put everything it wants there, because if something goes wrong and the validation layer of Vulkan spits out an error, instead of telling you that this went wrong with this texture, and then you see a huge memory number, which means nothing to you, if you have a name there and you named it, it will tell you specifically, oh, this, the velocity texture failed to transition or whatever. So I'm gonna name everything here. We're gonna go through this. We're gonna define all these arrays here. It's a little bit tiring for me as well, but it is what it is. So that's the depth. That's gonna be the velocity. That's gonna be the exposure. That's gonna be the output. Exposure. Oh. And that's gonna be the output upscaled color. Input depth. Input motion vectors. What was it? Was it that one? And now I'm gonna rename the things here, guys. Depth. I call things velocity in my engine, so I'm gonna type as velocity, and exposure, and output. And again, I'm gonna align everything. Don't laugh. I just like things to be aligned. Text depth. Add that thing here. Man, that's a little bit mundane to do, but we have to do it. Name velocity. Name exposure. And name output. Finally. And it wants the format of the textures as well. Let's do that. So that's the input texture, the first one again. Yep. So the format is simply text in get format. Oh. But it wants a Vulkan format, right? Yeah, VK format. Right, so I have a trick in my engine. I have a table, or an array I should say, called Vulkan format, where you can pass an array type format, which is the format of my engine, my own types, and it will convert it automatically to Vulkan. I've seen many engines do things like, if this is the format in my engine, then do that, if that, huge if statements. But I think the smartest way and fastest way to do it is this. So I have my formats here. That's my formats, or like my own definitions, and they have a particular sequence, right? That's 0, and that's 1, and so on. So, for example, I don't know, this first RGB format is number 10. So all I do is I take the very same formats from Vulkan, which might have different numbering sequences, and I just create my own array, and I put them in there. So I make sure that the Vulkan is 122, this format. But in this array, it's number 16 or 10 or whatever it was for me. So it will just fetch the right format. That's the most efficient way. Don't do huge if statements and switch statements. Just align everything with your engine in a second array, custom here. So that's why it's all convenient for us now. And also that's why, again, I felt so confident doing this FSR 2, which is quite complex on camera, because with my engine I pay a lot of attention in getting things right, in getting the architecture as good as I can get it, and in favor of doing ray tracing or any cool stuff. I take my time. I might take a year or two, just not doing anything like that, but perfecting the structure. That's why the engine is 7.5 years old and it's still going, because I never cut corners. I always try to do things right, even if it takes longer. It always pays off. Remember that, always. Everything that you leave like tech debt will come back to bites you in the ass. So that's the motion vectors. Text velocity. Come on. And there is so much stuff here, guys. I hope we get everything right. And that's the output, right? Yeah. Let's be very careful with everything, guys. So that's the input texture, that's the depth, the velocity, and the output. Cool. The names we don't really care so much, but I think they're correct. And now we pass the actual pointers to the resources. Let me stretch a little bit, guys. I'm sorry. I have been doing running lately and some dumbbells, and I feel some tension. So the resources. Let's go again. I guess it wants a VK image and then an image view. Yeah, okay. So we'll do it. We'll give it what it wants. Ask and you shall receive. VK image. That's the color. Unfortunate naming convention again. Text in. Get resource. That's the VK image. Okay, it's a void pointer in my engine for obvious reasons. So we cast it to a VK image. And now it wants the resource view. That's the SRV for the DirectX users. Image view for the Valkyrie users. There you go. And now let's do the same here. Yep, but be careful to change everything. So text, that's the depth, and that's the velocity. And here, get the resource, and that's the output. Oh, I forgot parentheses. So much typing, guys. So much typing. But we got this, I think. We'll see in the end if we got this. Text depth. And that's the velocity. Text velocity. And that's the out. I can't believe it, but we're actually done. It's the moment of truth, my friends. If we did everything correctly. Oh, not yet. That's the context. So let's name everything so it's very clear. Texture names, I guess. I guess these are indeed the texture names, not just something else. Dispatch. Yeah, so it's clear. Let's see first if it compiles. Let's take it slowly. I'm sure something will go wrong and we'll have to fix it. Wow, it compiled. Can't believe this. If it works in the first try as well, I don't know what I'm gonna do. It's gonna be impressive. Let's enable it. Wow, something is wrong. Let's go. That's the jitter. Let's see what we're doing wrong. Let's go to the renderer. Oh, yes, of course, guys. The jitter, I understood immediately that this was a jitter, and I came here because the jitter, it's supposed to be sub-pixel. What that means is small movements, right? It's not like these massive movements. And that's because I took what I think was screen space jitter and I just put it in the projection matrix, which is wrong. I have to divide it by the rendering resolution. And then we should get no crazy flickering. Yeah? If you did TAA, you know what I mean. Oh. Might have been some threading issue with my engine. It's not that perfect, the Vulkan backend. Yeah, some threading issue. So, let's see now. It shouldn't shake like crazy. Wow. It worked. Cannot believe this. Oh, some more artifacts. Ah. I know what it is already. Can you tell? Because this is a very specific artifact. It's not a trailing, it's not like a ghosting behind, it's like in front. It's as if the noise, what would normally be trailing, like ghosting behind the objects, is actually in front. It's like it knows, it's predicting ahead of time where the pixels are gonna go. I'm gonna tell you what it is. It's definitely the velocity. It's inverted. That's why the noise is going the opposite direction. So I think, if you remember, there was yes, the motion vector scale. Remember that? In the README file, it said motion vector scale. Yeah, it's using its own format, whatever, blah blah blah. And it said if you want to modify the velocity, just define a multiplier here. And I guess when FSR 2 does its thing, internally it will multiply with these guys here. So I don't even know what space it's using, but it looks correct for the most part. I know it's inverted, so I'm gonna give it a minus simply for its direction of the velocity. And let's see. Let's see if the noise goes away. Oh, it's gone. That was it. Guys, I can hardly believe it. Let's remove the motion blur and add the banding. Wow. That's insane, guys. You realize what just happened? FSR 2 just worked like that. 1 hour, 20 minutes. We had some issues, but thank God we fixed them. That's insane. That's insane. I wasn't expecting this, guys. People were telling me, you know, I'm nervous, hope you get it right. I wasn't expecting this to work just like that. I was expecting that I'm gonna make it work eventually because I trust my engine and my experience doing upsampling and studying upsampling. Even for Dirt 5, we did upsampling. Even before FSR 1 existed. But I wasn't feeling that certain. Wow. Okay, I want to do some comparisons. So the first thing is, that's FSR 2, okay? It's just a naming convention. Actually, you know what? Just so we're clear, I'm gonna go to the properties and I'm gonna rename the thing because we're gonna be playing around with it a lot now. Let's see. I'm gonna find where the render options. That's the window in the editor that has all the FSR 2 stuff, FSR 1 stuff. Right, so I'm gonna rename that thing to FSR 2. I just cannot see one all the time. And let's try now again. Right. Now, what I want you to see is that without any upsampling, right? Just a naive scaling from 720p to 4K. Remember how it looks. It's blurry a little bit. I don't know how much blurry as you can see from the Discord streaming. I'm gonna make it as big as I can for you guys. But don't worry too much, the guys from Discord, because this is gonna go online on YouTube, and it's gonna be twice the resolution. But what you can definitely see is all this simmering and crawling. Look at that. Look, it's just proud. You see all this simmering and crawling there. Simmering everywhere. Hope you can see that. The fences here on top of these houses, they're simmering. You know, everything is simmering. And if we enable FSR 2, and remember, this is 720p to 2K res. Like I'm really pushing FSR 2. I'm not giving it any, flexibility. And just look at that, it's insane. Look at how stable it is. See that? You see, you remember how these were flickering before? Look at these fences. You see how stable they are? It's just crazy. And remember that this is a basic implementation I did. I didn't do reactive maskings, reactive mask. I didn't do transparency and composition. I didn't enable sharpening. It's as bare bones as it gets, and it looks like good. Now what I'm gonna do is I'm gonna turn off FSR 2, and I'm gonna go to native 2K. Obviously it looks sharp and nice, right? I was expecting that. Isn't it amazing? 2K is nice and crisp, but you can see aliasing. You can see pixel crawling. Can you see it in the chat? You can see pixel crawling at 2K. Even these fences have aliasing. That's 2K native. And now 720, but with FSR 2. This is insane, guys. I was expecting it to be good, but this is crazy. That's for example, by the way, my monitor is 165 Hz. I doubt YouTube or the Discord channel can keep up with it. So if you see any screen tearing, it's basically the screen is too fast and the engine is too fast. I wasn't expecting that, guys. And yeah, so I guess when they say that what was it? Was it CPU Open? They said that sometimes it looks better than native. Did they say it on that loop? I don't remember. I mean, actually, we have proof. It does look better than native in some cases. Because it's a temporal filter again. Let's see that again. I cannot get enough. It's just, it's crazy, guys. Native. Crawling. 720. FSR 2. Stable. it's just ridiculous how good this is. And remember, it's really important, if you look at the sample, where was it, guys? Come on. Yeah, look, it has reactive masks. Again, a reactive mask is objects which don't have velocity buffers, velocity info, sorry, and they contribute less to the history, so they don't ghost a lot. Transparency and composition, so you can really push it. It can look way better. What I did was the most basic implementation, so you can make it fast. And the sharpening. Let's turn on the sharpening a little bit. I'm curious as to how it looks. Where was it? Enable sharpening, true. And the sharpness goes all the way up to 1, I think. Let's make it super sharp. I mean, super sharp is not that great because it's not exactly like native, but let's see. And it also does dynamic resolution. There is a lot of opportunities now for Spartan. Dynamic resolution, no TA for me to maintain. No FSR 1 anymore. It's too sharp for me. I don't know how it looks in the stream. For me, it's too sharp. But it's good. It's good. You have control. Oh, that was a crash for my engine. Yeah, texture distraction. But by the way, this is the Vulkan backend we're using. This, we'll use it for an entire stream. And that's the only issues we got. It took me like a year to get it that stable and performant. In any case, guys, that was it. It's 1 hour 26 minutes of streaming and it's done. Okay, I wasn't expecting this. Good. Do you have any questions? Anything you wanna ask or just say anything before we finish this? Nope. Okay then, my friends. Thank you very much for joining. I will be uploading this on YouTube in case you want to go and revisit something or see something in a high resolution. And I'll see you next time. Till then, take care and stay healthy, guys. Take care of yourselves. See you, guys.